Hello, hello everybody. Hello, how are you guys? What's up? How are you? How is everybody? कैसे हो दोस्तों? सारे बच्चे कैसे हैं? क्या कर रहे हैं? I just welcome you all. I just welcome you guys. Welcome everybody. Welcome. Let's just wait for a couple of minutes and we will start with the session. Let's just wait for a couple of minutes. Just a couple of minutes, guys. Meanwhile, this is what we are going to do today. As you can see, as you can see, we are going to have a look at exercise 8.4 from introduction to trigonometry. This is a very important exercise, and I hope you guys will be in this session till the end. So if you guys are in this session till the end, stay till the end, guys, and I am 100% sure that you will benefit from this session. Very good evening, very good evening, all my dear friends. Very good evening. That is so wonderful to have you guys in this session. So just give me a minute. We are getting ready and we will start this session in a moment. Just a minute. It is a very crucial exercise of class 10th chapter 8. Yes, best exercise in trigonometry, exercise number 8.4. So ऐसी exercise जो सबके चेहरे के हाव भाव बदल देती है. It changes everybody's expressions. Okay guys, welcome everybody. This is me, Netrapal Singh, and I'll be your host for today. We will be completing exercise 8.4 today, and stay with me guys. Without wasting much time, I just welcome everybody in this session. I welcome everybody. I welcome all of you to Vidya Academy, and let us just dive straight into this exercise. Now, before diving into exercise 8.4 question number 5, what we need to do is, one thing we need to remember, that always convert the ratios into sine and cos. The moment you do that, your path will become more clearer, and you will be able to realize what next step you're going to take. So don't worry, stay with me, and straight away we are doing this exercise. Let's do question number 1 first of all. So question number 1 is cosec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. So taking the LHS first of all, this is how you're going to write in your board exam if you encounter these questions. So cosec theta minus cot theta whole square, this is our LHS, yani ki left hand side, with this is your left hand side. Now cosec theta is nothing but 1 upon sine theta, as we all know, right? So cosec theta is now converted into sine theta, so that is 1 upon sine theta, minus cot theta is nothing but cos theta divided by sine of theta and the square of it. Now see, taking the LCM in the next step, you take the LCM, find that the LCM is sine theta, and the numerator becomes 1 minus cos theta, and once again it is the square. Now this can be written as 1 minus cos theta whole square divided by, now sine theta can be written as, sine theta square can be written as sine square theta, right? So what identity I will be using here is, I'll show you. First, let me write down 1 minus cos theta whole square divided by, now sin square theta can be written as 1 minus cos square theta. Now the reason we have changed sin square theta into 1 minus cos square theta is, or how we have done is, because there is this identity called sin square theta plus cos square theta is equal to 1. Now if you guys really want to enjoy this exercise, please keep your pen and paper handy and start doing this exercise with me. So if sin square theta plus cos square theta is equal to 1, sin square theta will be equal to 1 minus cos square theta, and this is what we have done here. In the next step, guys, let me do it for my children, for all my students who are a little bit weak like me in mathematics. Now 1 minus cos square theta can be written as 1 square minus cos square theta. Now do you remember this property, a square minus b square? Now a square minus b square can be written as a plus b into a minus b. Now for us, why I am teaching you this is because we have to apply this property in the denominator. So doesn't it look like this is a square minus b square? Now the next step should be 1 minus cos theta whole square divided by, now 1 square minus cos square theta can be written as 1 plus cos theta multiplied by 1 minus cos theta. Now do you see that there is 1 minus cos theta in the denominator and there is 1 minus cos theta whole square in the numerator. So one of the 1 minus cos theta has to cancel out. So we will be left with 1 minus cos theta divided by 1 plus cos theta, and congratulations, this is exactly your RHS. Can you see that? 1 minus cos theta upon 1 plus cos theta. Let me know in the chat box. Let me know in the chat box those guys who are doing this exercise along with me. Good evening, Lokesh Negi. Very good evening. Very good evening. Very good evening. Keep your pen and paper handy, guys. I'm sure you are doing this exercise along with me. Let me know in the chat box who all are having this exercise as dinner for today. So this is the dinner that we have today. Dinner. Right? Very good, Krish. Very nice. All those who have just joined us, we are doing exercise 8.4 from mathematics chapter number 8, and in that we are doing question number 5. Now I will erase all this thing that is written on the screen right now, and we will move on to the next question. I'm sure you guys understood the derivation, or you can say the proof. Now erasing this, let's move on to question number 2, and the question number 2 is cos a upon 1 plus sin a plus 1 plus sin a upon cos a. Now what we can do here is, guys, it's very easy, nothing to worry about. Now in the next step, what we have to do is we have to simply write what is LHS. What is LHS in the second case? Second case is cos a divided by 1 plus sin a plus 1 plus sin a, absolutely, divided by cos a, right? Now the next step is, see, already all the values they are in cos and sin, so we need not change anything first of all, and secondly taking the LCM here in the bottom or the denominator. So if you take LCM, all you are left with is, so cos a will get multiplied with 1 plus sin a. That's what happens, right? How do you take LCM? You multiply cos a with this part and you multiply this part with this part, and then you multiply the denominator. So 1 plus sin a multiplied by cos a, that is what I have written in the denominator. In the numerator you will be left with cos square a, because cos a multiplied by cos a is cos square a, plus 1 plus sin a whole square. Can we write that? Can we write that quickly? And let me know in the chat box those guys who are doing this exercise along with me. Now the next step will be simply do this thing, open this bracket. So cos square a plus, how do you open 1 plus sin square a? Remember the property, a plus b whole square. This is equal to a square plus b square plus 2ab. So in our case, if we are opening this bracket, now a is 1 and b is sin a square plus b square plus 2ab. That's what I am going to write here. So 1 square is 1 plus sin square a plus 2 times sin a is what we get on the top, and in the denominator we already have cos a times 1 plus sin a. Very nice, 1 plus sin a. Next step is, guys, see, cos square a plus sine square a. These two terms, they will add up to what? They will add up to, yes, 1. Very nice. So cos square a plus sine square a can be written as 1. Now plus, we already have this one, so 1 plus 1, plus what we are left with on the denominator numerator side is 2 sine a now. So 2 sine a whole divided by cos a multiplied by 1 plus sine a. For you guys, we have used this property, cos square a plus sine square a is equal to 1. So 1 plus 1 is 2. 2 plus 2 sine a divided by cos a multiplied by 1 plus sine a, right? That's what we get. It's a very beautiful exercise and it's a very beautiful equation now. So what you can do next is you can take out the common 2 and what you will be left with is 1 plus sine a. That's right. Wonderful. 1 plus sine a divided by cos a times 1 plus sine a. Wow, see how beautiful the equation has turned out to be now. Now 1 plus sine a in the denominator and 1 plus sine a in the numerator will cancel out. We will be left with 2 divided by cos a, and this can be written as 2 into 1 by cos a. Now what is 1 by cos a? What is 1 by cos a? Absolutely right. This is 2 sec a, and don't you think this is your RHS? Right? Can we have a big thumbs up in the chat box, or can we just show our appreciations in the chat box? Quickly guys, quickly. Let me know in the chat box whether you enjoyed this solution or not. It's a very, very, very interesting exercise. I am again and again repeating it. It's a very beautiful exercise. Very, very beautiful exercise. Are you guys able to see my screen? Yes, Janil. Wait, hold on. Why am I not seeing this? People. Krish, is the screen visible? Yes, Janil. Okay, yeah. Okay, my laptop got stuck, I believe. Alright. Janil, मैथ्स तो बेटा वो पहले से ही स्टार्ट था, पढ़ाते तो तेरे सर हैं, फिजिक्स केमिस्ट्री मैथमेटिक्स, वो तुझे पता ही है. पीसीएम के बादशाह the Dawn. The whole school is afraid of the Dawn. Alright, so I hope you guys have done this question. Wonderful. Now moving on to the next question, guys. Next question is question number 5th, third part. So already the hint is given here. We have to convert into sine and cos, but this is not a hint because this is our standard protocol. What we do once we look at the questions in trigonometry, we immediately convert them into sine and cos, and that is the first rule that we have to follow in exercise 8.4. Alright, let's look at this exercise. So on the left hand side we have, let me write down the left hand side, LHS. What is LHS? It is tan theta upon 1 minus cot theta plus cot theta divided by 1 minus tan theta. Next step is converting these tan theta and cot theta values into sine and cos. Now tan theta is nothing but sine theta divided by cos theta divided by, can we write 1 minus cot theta is written as cos theta divided by sine theta plus cot theta, again it can be written as cos theta divided by sine theta. Denominator we have 1 minus sine theta divided by cos theta. Absolutely. Now the next step should be, we have to take LCM here itself. So write down sine theta divided by cos theta whole divided by, can we say sine, the denominator here is, can we say the LCM here is sine theta minus cos theta whole divided by sine theta. That's what should be coming here, plus on the right hand side it should be cos theta divided by sine theta in the second term, and that should be cos theta minus sine theta whole divided by cos theta, right? Yes. All right. So next step is guys, sine theta. I'm continuously and constantly reading your chat messages. All right. So next, what we can do here is see sine theta divided by cos theta, and this whole term is in the denominator. So what I'll do is I'll simply use the multiplication sign, but for that I'll have to reciprocal the terms. That means sine theta will come on the top, and sine theta minus cos theta, this will come here, plus once again cos theta divided by sine theta multiplied by cos theta whole divided by cos theta minus sine theta. It's very beautiful. This is equal to sine theta multiplied by sine theta is nothing but sine square theta divided by cos theta into sine theta minus cos theta, plus this is cos square theta, right? So cos theta into cos theta is nothing but cos square theta divided by sine theta multiplied by cos theta minus sine theta, right? Cos theta minus sine theta. Now there is this one thing that can be taken out common here, and I'll show you in the next step, which I'm going to write here right now. So sine square theta divided by cos theta, sine theta minus cos theta is what was available in the first term. Now what I will do is I will take out minus sign from this bracket common, and I'll multiply that minus sign with this plus, so this will become minus now. On the numerator side you have cos square theta, in the denominator you will be left with sine theta minus cos theta. Yes, that's right guys, this was the key turning point in this proof. Alright, this is equal to sine square theta. Okay, let me just do one thing. Can I just erase it? Eraser, yes. So I wish to erase it because I want to write something else. Pen. Yes, absolutely. So taking out your sine theta minus cos theta as common, so 1 upon sine theta minus cos theta can be taken out common. In the numerator, in the first term, we will be left with sine square theta divided by cos theta minus cos square theta divided by sine theta. Very nice. Alright. Let me know in the chat box once you have done till this point, because I need to use the space which is available to me on the top. I need to write more here in this proof. So I'm erasing LHS. I'm erasing the top side. I'm erasing whatever was written on the top. I need that space for doing some more calculations, derivations, proofs. Okie dokie. Yes. Just hold on guys. Just hold on. I hope you guys are solving this exercise with me. This question is a very beautiful question. In fact, this question, part number 3. Yes, it's a star question, flag question, important question. Mark it as important for board exams. Also mark it as important for your half yearly exams. Cool now. So we are here, right? So 1 upon sine theta minus cos theta. Now in the next step, we will get 1 upon sine theta minus cos theta multiplied by, see, this will be sine cube theta minus cos cube theta, and we took the LCM and this turned out to be cos theta times sine theta, right? So in the next step guys, now there is this property which says a cube minus b cube can be written as simply a minus b times a square plus b square plus ab. If you don't know this property, don't worry, there is nothing to worry about, because you have to remember it. Most of the people do not remember it. Don't worry, just remember this property and we are good to go. So alright, on the top side in the numerator, I am going to invoke this property. So a is sine theta and b is cos theta for me, looking at this term right here. So this can be written as sine theta minus cos theta, first of all, a minus b, times a square plus b square plus ab, which means sine theta times cos theta, and this whole thing is divided by sine theta minus cos theta multiplied by cos theta times sine theta. Now see this, have a look at this particular portion. Sine theta minus cos theta from the numerator and denominator cancel out. Now sine square theta plus cos square theta, no need to write, it is 1, right? That property sin square theta plus cos square theta, that is equal to 1, plus we have sin theta cos theta divided by cos theta times sin theta. We are just about to complete the proof now. So this can be split into 1 upon cos theta times sin theta plus sin theta cos theta divided by cos theta times sin theta. It's very beautiful now. See, sin theta upon cos theta, they cancel out each other. We are left with 1 upon cos theta times sin theta plus 1 plus 1. Let me just erase the last portion also. Let me just quickly erase it. Gone. Phew. So today I was watching Thor, Love and Thunder, and then I realized I have a class to take today, and then here I am teaching you guys exercise 8.4. Welcome Vyom, welcome Krish, Janil, everybody, welcome to this session. Now those who have not yet subscribed to the channel, please do that, because it is a protocol you have to follow, and fan following हमारी बनी रहनी चाहिए. Next is 1 upon cos theta can be written as, guys, sec theta, and 1 upon sin theta here can be written as cosec theta, plus already you have 1, and this is equal to RHS. Yes or no? This is equal to RHS, right? So RHS, sec theta cosec theta plus 1 is nothing but your RHS, 1 plus sec theta times cosec theta. Hence, see, this is also a protocol, hence proved. Hence proved. Yeah, people are laughing. Laugh as much as you can, you people. Very nice. So moving on to the next question now. I hope you guys have completed question number, the third part from question number 5. Now moving on to question number 4th. This is also once again a very, very beautiful question. See, he is giving us already the hint that we have to simplify the LHS and the RHS separately. We have to simplify the LHS and the RHS separately. So let's do that right now. Let's do that right now. Are you guys with me? Let me know in the chat box. Let me know in the comment box. I'm reading your chat box right now. I'm reading all your chats now. So if you have pen and paper handy, raise your hand. Raise your hand if you are a boy. Raise your hand if you're a girl. Raise your hand if you're a good student. Raise your hand if you are loving this. Raise your hand if you're singing. Basha, South Bhopal का बादशाह. व्योम, साउथ भोपाल का बादशाह नहीं. अभी पब्लिक को इतना पता नहीं है कि असली नराची में किसी और के कदम आ चुके थे. पर वो अनजान थे कि नराची में किसी और के कदम पड़ चुके थे, है ना. रॉकी भाई सलाम. चलो, ऑलराइट, लेट्स डू क्वेश्चन नंबर 4. So 1 plus sec A divided by sec A is the LHS, right? So LHS is equal to this. Stay with me, guys. Now the first step is to convert sec A into sin and cos. So what we will write here is 1 plus sec A can be written as 1 upon cos A first of all, and this whole can be written as 1 divided by cos A, because we have converted sec A into cos A. Now sec A is equal to 1 upon cos A. This is the property that we have to remember. Now taking LCM in the numerator, you get cos A plus 1 divided by cos A, right? And 1 upon cos A can be written as multiply by cos A upon 1. So cos A cancel out, and you are left with 1 plus cos A. You are left with 1 plus cos A. Am I right or wrong, guys? You are left with 1 plus cos A. Absolutely. Alright, so we will not separately solve the RHS and LHS here. We will do one thing right away. So we will try to make sin square A in the numerator, and see, this is just one step away. We are just one step away from the final answer. So what we will do here is we will multiply the numerator by 1 minus cos A, and we will also multiply the denominator by 1 minus cos a, the same value. See, we are not doing anything extra. What we are doing here is we are simply multiplying this 1 plus cos a by 1, because see, 1 minus cos a, 1 minus cos a will eventually cancel out, and the answer will be 1 here, right here. So this can be written as 1 plus cos a times 1 minus cos a, and this whole is divided by 1 minus cos a. Now remember the property, boys. A square minus b square is equal to nothing but a plus b times a minus b. Is not the vice versa true also? A plus b times a minus b can be written as a square minus b square. So we take a as 1 and we take excuse me, we take b as cos a. So what we can do here is we can write 1 square minus cos square a whole divided by 1 minus cos a. Now few students, they mistakenly cancel out this 1 minus cos a and the square here, but we can't do that because that is incorrect. What we can do here is 1 square minus cos square a is nothing but 1 minus cos square a, because 1 square is 1, divided by 1 minus cos a. I'm just delaying the answer. 1 minus cos square a is nothing but, boys, this is sine square a divided by 1 minus cos a. How? Because cos square a plus sine square a is equal to 1, right? And therefore sine square a turns out to be 1 minus cos square a. Give me a thumbs up if you liked this proof. If you liked the proof. There is no RHS, Vyom. There is no RHS in this question. There is no RHS in this question. Or you want me to solve the RHS part also? Is that it? Is it? You want me to do the RHS again? Is it? No. I mean, that there is no such requirement here, right? Yeah, good. Very nice. There's no such requirement. We already got the value RHS. We have already proved it. Okay then, so next, moving on to the next question. I am erasing whatever is written on the screen. Moving on to the part number 5. This is, trust me guys, it's a very, very, very beautiful question. It's a very beautiful question. This is one question wherein we will not be converting the values into cos a and sin a. In fact, we will be doing the reverse of it. So we will be converting this cos a into cot a somehow. And how do you do that? Let me just prove it on your screen right now. So on the left hand side, we have LHS is equal to cos a minus sin a plus 1 divided by cos a plus sin a minus 1. I hope we have Sandeep along with us, our very smart and intelligent and the most extraordinary student. So this is equal to, now okay, before putting equal to sign here, what I want to do is I want to convert this cos a into cot a somehow. How do you do that? You do simply one thing. You divide the numerator and denominator all together by sin a. That's it. Divide this. So cos a divided by sin a minus sin a divided by sin a. This is the numerator value itself, plus 1 upon sin a is written on the top, and at the on the denominator side we have cos a divided by sin a plus sin a divided by sin a, right? We have divided each term. Okay, there should not be a minus sign here. Let me quickly erase it. So we have divided each term by sin a, and that's what we have done so far, minus 1 upon sin a. So see, every term is having a sin a. Now cos a divided by sin a is nothing but cot a, minus sin a by sin a is 1, plus 1 upon sin a is nothing but cosec a, divided by cos a by sin a again can be written as cot a, plus 1 because sin a by sin a is 1, minus cosec excuse me just a second cosec a. Let me know in the chat box if you guys have come so far. Yes or a no, guys? Yes or a no? Quickly let me know in the chat box. Yes, I can read your chats. I can simply read your chats. Don't worry. I'm reading your chats. Cool then. So next step would be, guys, I am just trying to manipulate something here. Stay with me and there is nothing to worry about. So in the denominator side, we have 1 minus cosec A plus cot A. And in the numerator, I can write this value as cot A plus cosec A. This minus 1 can be written as, cot square A minus cosec square A. Right? Cot square A minus cosec square A. Can we do that? Oh, I think it should be, because the properties tells us cosec square A is equal to 1 plus cot square A, right? So it should be cosec square A minus cot square A. Very nice. Very nice. Yeah. Let me just change it. So there is just a minor change, because the property tells us, the property says that cosec square A is equal to 1 plus cot square A. So here we can say cosec square A minus cot square A can be equal to 1, right? So instead of writing 1, this one, I am changing this one into cosec square A minus cot square A. It's beautiful. Cosec square A minus cot square A, right? Next is guys, invoke once again you invoke that same property, and the property was A square minus B square. A square minus B square is nothing but A plus B times A minus B. So this is equal to cot A plus cosec A. We leave this term as it is, minus, now cosec square A minus cot square A can be written as cosec A plus cot A multiplied by cosec A minus cot A, and this thing is whole divided by 1 minus cosec A plus cot A plus cot A. Let me just erase the left portion of my screen. I wish to use this to prove to prove. Meanwhile, keep writing your answers in the chat box. Yeah, wonderful. So we have students, participants from Kuwait, we have people or students from Lebanon, and that is a very beautiful sign. Alright, so see, cot A plus cosec A this term and cosec A plus cot A this term, both the terms can be taken out common. So taking out common cosec A plus cot A, this is common. In the bracket we are left with 1 minus cosec A minus cot A. That's what is left here, and this is divided by 1 minus cosec A plus cot A plus cot A, right? Yes or no? Yes. This can be written as cosec A plus cot A multiply by, see, 1 minus, opening this bracket will give us 1 minus cosec A. Now this minus and this minus, they will multiply with each other and we will get plus cot of A. Pardon my handwriting, it is not that good, I know it, but I love it. Alright, so in the denominator side we have 1 minus cosec A plus cot A. In the numerator we have 1 minus cosec A plus cot A. These two values, they will cancel out each other and we will be left with cosec A plus cot A. I am writing it here. So cosec A plus cot A, and woohoo, this is your RHS. This is your RHS, right? A big thumbs up to me, and I'm the best. Am I not the best? Tell me I'm the best. Are you just kidding? But I'm the best. So who do we have with us right now? Do we have Krish and Vyom here only, or we have other people also? Wait, hold on. Oh yes, I am the best. Alright, please, meanwhile, those who have joined this session right now or just now, please do like this session, share this session with your friends, and subscribe to the channel. That will really help us out. And thank you, guys. So let us go to the next question now. Let's go to the next question now. OMG. I think we missed the part that is this part, because my photo is there, right? It's okay. You will eventually get this. Anyways, I am not going to use the right hand side now. I will be using the left hand side, but we don't have space. Okay, all right. I'll do one thing. I will make markers here. Let me do that right away. So I will not be using this box right here. Okay. Yes. Now we have completed question number 5. Now let's move to question number 6. So LHS side, we have under root of 1 plus sine A divided by 1 minus sine A. This is our LHS. Next thing that we have to do is simply LHS is equal to this. So let's do one thing, guys. Let's multiply the numerator and denominator by one thing, and that one thing will be this 1 plus sine A divided by 1 minus sine A. This is the question. Now we are multiplying the numerator and denominator inside the square root with 1 plus sine A divided by 1 plus sine A. It makes sense, right? Because eventually we have multiplied by 1. So 1 plus sine A into 1 plus sine, this will become 1 plus sine A whole square under root divided by 1 minus sine A into 1 plus sine A. Remember the property A plus B times A minus B will give you A square minus B square, right? So this is 1 minus sine square A. And this can be written as, boys, see, 1 plus sine A square under root will cancel out. So we will get 1 plus sine A in the numerator. See, this square and under root will cancel out each other. We will get 1 plus sine A. In the denominator, we have under root of 1 minus sine square A, and that is nothing but cos square A under root. So this can be written as 1 plus sine A whole divided by cos square A under root is nothing but cos A. Simplifying the values, we get 1 upon cos A plus sine A divided by cos A. Now 1 upon cos A is nothing but sec A plus sine A upon cos A is nothing but tan A, and this is our HS standard protocol, hence proved. Hence PROVED, proved. Hence proved. Right? Let me know in the chat box how many could do it before me. Let me know in the chat box, guys, how many could do it before me. We are on question number 6 right now. 6th. Let's move on to the next question now. I'm erasing this part now. Let me just once again make a box here because my face will be here. Next question number, 7th question. Guys, let's do one thing. Why don't you guys try 7th part now? It's very easy part. It's probably the easiest part, and don't worry, you will get the answer very easily. Do not worry at all. So try 7th part on your own. I am going to do this 8th part now. This question is also a very big question, boys. Now 8th part is LHS here is sine A I'm not going to write LHS now. I'll simply try try solving the question now. So sine A plus cosec A whole square plus cos A plus sec A whole square, this value need to be converted. This value need to be converted. What can be done here is we have to open the bracket now. So sine A plus cosec A can be written as sine square A plus cosec square A plus 2 times sine A cosec A. Now so far I have simply opened this bracket. Let me just erase so that it is not blocking your view. Let me just erase this part here right now. Right here. Boom, 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 boom. Okay. So sine A plus cosec A whole square has been opened as sine square A plus cosec square A plus 2 sine A cosec A, invoking the property. Do you remember the property? A plus B whole square is equal to A square plus B square plus 2AB. Right? There is the plus sign here. Now this is the plus sign on the top. Plus cos A plus sec A whole square can be written as cos square A plus sec square A plus 2 cos A sec A. Now sine square A and cos square A, both these terms, they will add up and you will get 1, right? Yes. Plus you have, see, 2 sine A cosec A, you have plus cosec square A here, you have sec square A here. Write down cosec square A plus sec square A as it is, plus now writing this 2 sine A multiplied by what is cosec A? Converting this cosec A into sine, you get 1 upon sine A, right? 1 upon sine A plus 2 times cos A times sec A can be written as cos A. Now cos A cancel out, sine A cancel out. In the next step we have 1 plus 2 plus this 2 plus these values. So cosec square A plus sec square A. We have 2 plus 2 plus 1 which is equal to 5, plus now cosec square A can be written as 1 plus cot square A plus sec square A can be written as 1 plus tan square A. This is a simple property. So 1 plus tan square A. Now add these values. So 5 plus 1 plus 1. What do you get? 7 plus. You are left with cot square A plus tan square A. And kya maja bhai? This is equal to RHS. Hence proved. Yeah, hence proved. Na, this is like a lollipop. So we give it to every examiner. Wow, Grish, nice, congratulations, you did it before me. Isn't it? Hence proved is a standard protocol. We have to write it every time this is like a chair, this is like a trophy that we get once we complete the proof of any question in mathematics. Yes, let me know in the chat box how was the question. Did you get scared, or was it too easy, or what? Was it too easy or what? Okay, yeah. ठीक है, चलो, let's do another question now. Let's move to question number 9, right? Let's move to question number 9. Alright, I'm deleting whatever is written on the whiteboard. Once again, making a box so that this part is not missed out. Alright, next moving on to the 9th question. The 9th question, LHS is, we have, now in this question we have to separately solve LHS and RHS. So LHS is cosec A minus sine A times sec A minus cos A. This can be written as, convert this cosec A into sine A, 1 upon sine A minus sine A multiplied by 1 upon sec A can be written as 1 upon cos A minus cos A. This is equal to, taking the LCM we get 1 minus sine square A, right? Because this sine A will get multiplied by this sine a, and in the denominator we will be left with sine a, and in this bracket we can write 1 minus cos square a divided by cos a. Now you have guessed it correctly. 1 minus sine square a can be written as cos square a divided by sine a, multiplied by 1 minus cos square a can be written as sine square a, and this is divided by cos a. So 1 sine a and this square will cancel out, 1 cos a and this square will cancel out. You will be left with sine a times cos a, and this is your LHS so far. This is your LHS so far. It's like sweet after the it's like sweet after the dinner. Oh boy. Oh boy. Yes, keep it coming, boys. So LHS we have sine a cos a. I eat mathematics for dinner, right? Is that what you want to say? Yeah. I chew mathematics and I just, leave it for my Bruno. There's my Bruno. He's sleeping. Alright, so I let me just quickly delete whatever is written on the board. I'm erasing it. So so far we have got sine a multiplied by cos a, and leave this value as here. I mean sine a cos a is what we got in the left hand side. Now solving the right hand side, RHS. On the RHS you have 1 upon tan a plus cot a. RHS is equal to 1 upon tan a can be written as, guys, sine a divided by cos a, plus cot a can be written as cos a divided by sine a, right? This is equal to 1 upon, taking the LCM in the denominator, you get sine square a, because you multiply this sine a with this sine a, plus multiplying this cos a with this cos a will give you cos square a. This is divided by cos a times sine a. This is equal to 1, and now I'll do one thing. Now I'll keep this one as it is, 1. Now I will use this denominator by writing it like this. So I'll take the reciprocal of it and multiply it. So cos a times sine a divided by sine square a plus cos square a. Now sine square a plus cos square a, see, 1 multiplied by any value is nothing but the value itself. This is not a minus, it's a mistake. So accidentally I put my eraser. Let me just use the eraser now, because it will confuse you guys. Yes. Alright, so 1 multiplied by any number will give you the number itself. So we have the same number in the numerator, that is cos a times sine a. In the denominator we have sine square a plus cos square a, and that is equal to 1. We can write this value as sine a times cos a, and this is equal to this. So hence proved. Hence proved, right? Yuppie use. Are you guys ready for the last question? Are you guys ready for the last question? Are you excited? Do you have that adrenaline rush? Huh? Hi, kya rahi? Huh? Do you have that adrenaline rush? Yeah, keep it coming. Mind my excitement don't da. Anji. Excitement Ajay. Do we have that excitement? Yes. Alright, moving on to the next question, last question. This is the most important question, guys. This last question is the most important question, although it is a very, very easy question. It's very easy, but let's do it. No need to worry. Let's do this question now. Let me erase the board now. So what we have to do is we have to prove that these two values are equal. Also, this is equal to tan square a, right? So we will start with, let's say, 1 plus tan square a divided by 1 plus cot square a. Let's take this as LHS for now. So this is equal to 1 plus tan square a upon 1 plus cot square a. Remember the property, 1 plus tan square a is nothing but sec square a. So you wrote sec square a on the top, and 1 plus cot square a is nothing but cosec square a. Now sec square a can be written as 1 upon cos square a, and cosec square a here can be written as 1 upon sine square a. So this is equal to nothing but sine square a divided by cos square a, and sine a upon cos a is tan a, so this is equal to tan square a. This is equal to your right hand side tan square a. Yes or no, guys? Come on, quickly let me know in the chat box that whether you understood this or not. Quickly let me know in the chat box, boys. Quickly. It's very easy peasy. No need to panic. Right? So let's do the last part now. Shall I erase it? So we have already proved that 1 plus tan square a upon 1 plus cot square a is equal to tan square a. All we are left with is if we can prove 1 minus tan a whole square upon 1 minus cot a whole square is equal to tan square a. So let's do that. Let's do that part also. So we have 1 minus tan a divided by 1 minus cot a whole square. What is the next step? We have to convert this tan a into sin a cos a and cot a into sin a cos a. Last step, guys, last question. Those who have still not subscribed to my channel, I'll come to your home and I'll make sure that you do that. So 1 minus tan a can be written as 1 minus sin a divided by cos a. Of course, guys, this really gives an encouragement and appreciation. So the team gets boosted up. So 1 minus cot a can be written as cos a divided by sin a. So this can be written as like this, and we have a square here, right? So next step is taking the LCM in the numerator. We get cos a minus sin a divided by cos a, right? And in the denominator we have sin a minus cos a whole divided by sin a, and this is in a bracket with a square on it. This is equal to, guys, now can I write this as cos a minus sin a divided by cos a, and like this, can I write this as sin a divided by sin a minus cos a whole square? Is this visible to you? Is this visible to you? If not, let me write it here. So what I am doing here is cos a minus sin a in the numerator was like this, cos a minus sin a upon cos a, right? Cos a multiplied by sin a, taking the reciprocal of the denominator, so sin a divided by sin a minus cos a. Yes, and we have a square here. Absolutely. Next step is, guys, so sin a divided by cos a and cos a minus sin a divided by sin a minus cos a. Can we do one thing, guys? Can we take the square of all these values? So this will be cos a minus sin a whole square, right, into sin square a, individually taking the square because these values are in multiplication. I would have taken minus sign here common, because, but most of the students might have gotten confused. So that's why I am not doing that step. So cos a square will be cos square a, and sin a minus cos a whole square will be written here. So cos a minus sin a whole square and sin a minus cos a whole square, both these squares are same. So you can simply cancel out these squares and you will be left with sin square a divided by cos square a, and congratulations, this is equal to nothing but tan square a, which is equal to your, hence proved, walla bhaiya, hence proved. So let me know in the chat box, guys, whether you like the solution part of exercise 8.4 or not. 8.4, the most brilliant exercise, the best exercise of trigonometry, the best exercise I can say. It's the best. Love it. Simply love it. Amazing. So that's it for today, guys. Thank you so much. Let me know in the chat box once again, how did you like the session? Whether you like the session, whether you like these sessions or not, whether you think these sessions are helpful to you at all. just let me know in the comment box. And that's it for today. Thank you so much. We'll see you in the next class with a new chapter. Till then, bye bye. Take care. Hasta la vista, baby. And yes, of course, I'm the best. बादशाह है मैं साउथ बोबल का फिजिक्स केमिस्ट्री मैथ्स बादशाह है रे चलो बाय गाइस थैंक यू गाइस टेक केयर बाय